What if I told you the future of computing isn't made of silicon, but something far more alive? Back in 2021, researchers shocked the world by training a tiny cluster of brain cells in a petri dish to play Pong using electrical signals. It was a glimpse into something revolutionary. Fast forward to 2025, and that early experiment has evolved into something even more mind-blowing. The Cortical CL1, the world's first biological computer that can run code. Packed with 800,000 living neurons, this shoebox-sized machine doesn't just process data. It thinks, learns, and adapts like a living brain. It sips just 30 watts of power and could redefine AI, robotics, and even medicine. But how does it work? And what does it mean for the future of technology and humanity? Let's dive in. It's March 2025, and Cortical Labs unveils the CL1 in Barcelona, the first biological computer. Picture this, 800,000 living human neurons in a shoebox-sized unit, sipping just 30 watts of power. This isn't sci-fi, it's real, and it's here. Instead of using traditional silicon chips, the CL1 utilizes living neurons to process information, learn, and adapt in ways that standard computers simply can't. The potential is incredible. From advancements in AI to new medical uses, the Cortical CL1 could change our understanding of computation entirely. Dr. Hon-Weng Chong, the founder of Cortical Labs, calls it the culmination of a vision that powered us for nearly 6 years. A mission to democratize this tech for researchers everywhere, with the real impact coming from what they build next. But how does it actually function? What sets it apart? And what hurdles does it need to overcome? Join me as we explore this groundbreaking technology, looking into its origins, capabilities, and the future it can shape. Cortical CL1 is an innovative biological computing system that combines living neurons with digital interfaces, enabling software to engage with organic intelligence. Unlike conventional computers that rely on binary code for processing information, CL1 utilizes neuronal activity to tackle complex tasks, offering a level of adaptability that hasn't been seen. You can think of it as a blend of biotechnology and artificial intelligence, a machine capable of learning, solving problems, and even evolving over time. Created by Cortical Labs, CL1 is based on the concept of synthetic neuroplasticity, which allows it to rewire itself in response to information. This unique feature enables it to handle tasks that go beyond traditional programming, making it a promising option for AI training, autonomous systems, and biomedical research. Here's the game changer. You can deploy code to the CL1. Developers use a system called BIOS, Biological Intelligence Operating System, to send instructions through a 59 electrode array, zapping 800,000 neurons with tiny electrical pulses. The neurons react, adapt, and shape their behavior in real time. It's like coding a living brain, pushing machine intelligence way beyond what we've seen before. Cortical CL1 fundamentally combines biological and digital elements through a hybrid architecture. It includes 3 key components. Neuronal cultures. These are living brain cells sourced from humans or animals, grown in a controlled setting. Electrode arrays. Serving as a link between biological neurons and digital signals, these arrays facilitate real-time data exchange. AI-driven software. This allows for dynamic programming, enabling developers to set tasks and see how the biological system responds and learns. Functionally, CL1 works in a way that's quite similar to a neuron, but it incorporates biological plasticity. Neurons are stimulated by electrical impulses, and their reactions are analyzed, much like how our brains process information. Unlike traditional silicon-based processors, CL1 is always adapting and improving its performance based on experience. This allows it to tackle problems without relying on predefined algorithms, responding flexibly to new challenges. Through real-time feedback, the CL1 fine-tunes itself, perfect for autonomous AI, decision-making, even mimicking human thought. Those 800,000 neurons keep humming for up to 6 months, making it a research powerhouse. It's not just fast, it's smart and adaptable. But here's the catch. That incredible adaptability raises big ethical questions we can't ignore. What distinguishes Cortical CL1 from conventional silicon-based systems? Its adaptability, efficiency, and energy consumption are key factors. Adaptive learning. Unlike fixed algorithms, CL1 evolves its processes naturally, enabling continuous self-improvement. Energy efficiency. Biological neurons use significantly less energy than silicon chips, which could transform AI computing by greatly lowering power demands. Parallel processing. Traditional CPUs handle tasks one at a time, while neurons can process information simultaneously, leading to quicker and more efficient solutions for complex problems. Realistic AI training. Since biological neurons operate similarly to those in the human brain, CL1 can train AI in a more lifelike way, enhancing the realism and adaptability of AI models. Minimal hardware limits. Rather than cramming more transistors to increase computing power, CL1 utilizes the natural scalability of neural networks, allowing for enhanced computational capabilities without hardware constraints. The creation of CL1 didn't happen suddenly. It was the result of many years of hard work in fields like neuroscience, artificial intelligence, and bioengineering. While the initial ideas of biological computing emerged in the 1990s, real progress was made only when researchers figured out how to cultivate and control living neurons in laboratory environments. Cortical Labs, the team behind CL1, achieved a significant milestone in 2021 by training a system based on brain cells to play Pong. Following this success, they shifted their attention to developing a version that could be deployed alongside contemporary software. By combining AI modeling, microfluidics, and bioelectric stimulation, researchers created an interface that enabled real-time programming of biological neurons. By 2025, CL1 had progressed beyond the laboratory and was undergoing tests for practical applications in fields like AI, robotics, and healthcare. This development journey showcases how collaboration across various disciplines, from geneticists to computer scientists, has turned what once seemed impossible into a reality. But how do you build a computer with living neurons? It starts in a lab, where human stem cells, reprogrammed from donated blood, are bathed in a nutrient-rich soup. Over weeks, they grow into 800,000 neurons on a silicon chip, wired up with a 59-electrode array to zap and read their signals. That chip gets tucked into a shoebox-sized unit, packed with pumps, filters, and temp controls to keep the neurons alive and buzzing for 6 months. It's half biology, half engineering, a delicate dance to merge brain power with tech. This tech's a game changer, but it comes with big ethical questions. Could the CL1's 800,000 neurons spark self-awareness? What if it did? How do we handle sentient AI? Then there's privacy. Its organic learning's tough to predict. Could that open cybersecurity risks? Sourcing human neurons raises sourcing debates too. And regulators, they're scrambling to catch up with this new beast. Cortical Labs isn't blind to this. They're pushing an animal-free testing angle and working within ethical frameworks. Still, the bioethics debate's just heating up, and CL1's right at the center. These concerns are not just theoretical. They must be tackled before we can roll out this technology on a large scale. The discussion about bioethical AI is just starting, and CL1 is at the forefront of this dialogue. Cortical CL1 hit the market this month, March 2025, at $35,000 a pop, with shipments starting June 2025. It's not for your living room yet, but research labs, AI firms, and biotech companies are already snapping it up. From training smarter AI to modeling brain diseases, it's ready to roll. In the coming years, we might see CL1 applied in areas such as advanced AI training. Thanks to its adaptability, CL1 is an excellent candidate for the next generation of machine learning models. Medical research. The modeling of neurological diseases and advancements in brain-computer interfaces, BCI, could greatly benefit from CL1's biological framework. Cybersecurity and AI defense. Its distinctive learning abilities could offer innovative solutions to the ever-evolving digital threats we face. While it may take years for consumers to have access, businesses and technology innovators are already looking into ways to incorporate CL1 into their operations. The key question isn't whether it will hit the market, but rather when and in what form it will arrive. The possibilities of Cortical CL1 go well beyond what we see today. Picture this, truly autonomous AI with human-like understanding. AI systems that not only react to inputs, but also grasp and learn from their surroundings in an intuitive manner, combining biological and digital intelligence. A partnership between humans and AI where biological computing boosts human abilities. Transformed computing architectures, moving past the constraints of silicon, resulting in faster, more efficient, and even eco-friendly AI solutions. If CL1 is successful, it could signal the beginning of a new age in computing. An age where AI is not merely programmed, but nurtured, evolving much like a living being. Cortical CL1 signifies a fundamental change in our perspective on computing. Starting from its early days with neurons playing Pong, it has transformed into a deployable learning machine that is reshaping the fields of AI, machine learning, and computational efficiency. However, with such innovation comes a great deal of responsibility. Ethical issues, regulations, and long-term consequences need to be addressed thoughtfully. We're stepping into the biological computing age, smarter AI, medical breakthroughs, a fresh take on intelligence itself. The CL1's leading the charge via the Cortical Cloud's wetware as a service. Labs worldwide can tap in, no fancy setup needed. Dr. Honweng Chong says, "We've seen strong interest from top researchers globally, but to truly unlock its potential, wetware as a service will let millions of innovators turn the CL1 into real-world impact." The future's here, and it's electric. So, what do you think? New intelligence on the horizon, or ethical minefield ahead? One thing's clear, CL1's rewriting what's possible. Like this? Hit subscribe, tap the bell, stay in the loop. If you found this video interesting, please remember to like, subscribe, and click the bell icon so you stay updated on exciting innovations like this.